Okay, hello everybody. My talk is going to be about price oracles and how we can use signed messages to move some computations off-chain and save on gas costs and increase security and hopefully some other things that I'm going to be mentioning. So my name is Mariano Conti. I'm the head of oracles at MakerDAO. And I'm going to talk quickly about what is an oracle in the context of a blockchain. Blockchain knows nothing about outside data. So for smart contracts like ours, the DAI credit system, where we need to know the price of Ether, the price of MKR, or the price of any asset that we eventually use, we need a way to input that data from the outside world into a smart contract, and that is what we call an oracle. And the way you do decentralized secure oracles is usually to have a lot of different people sending data to the blockchain and then aggregating that data in a way that is safe and that other smart contracts can use. So I'm going to need a little bit of help from the audience now, and please don't look at your phones. I need 3 people to give me the price of Ether in USD. 220. Okay. How much? 170. 235. Okay. Let's do this. So, okay. So up there we have the official ETH/USD price feed for Maker. It's 2018.75 at the moment, and the audience medianized is 220, so that was actually very, very good. Of course, in the real world, you would not have only 3 sources, but I think for this, it went pretty well. So let's look at the naive implementation. Let's say we have those 3 prices that the audience gave us, and there's 3 smart contracts that continuously push prices to them. And let's say they pushed these prices. So as we saw, if we have a medianizer contract that reads from all of these 3 feeds, we can see that calculates the correct median, and anybody can use this price feed for whatever they need. So how this would happen is every time an oracle updates, it would trigger the medianizer that would read from these authorized sources. It would compute the median on-chain, meaning that it would grab, as you can see, these prices are not sorted. It would need to sort 170, 220, and 235, then calculate the median. If this were an even number of feeds, it would have to grab the 2 in the middle and get the average. So as you can see, there's a lot of computation going on in the blockchain, and this is like not a very good way to do this. Some of the drawbacks also include like high gas costs. It's a lot dependent on network latency. So when you have like a CryptoKitties event and you have Oracle sending transactions and these transactions are not getting mined, for something like price feeds where you need real-time price data, you can have a really nasty consequences if your contracts are not up to date. Also, every single oracle needs to have ETH balance so they can send transactions. And of course, that means they need to have a sync parity or geth node running, right? You can probably use Infura, but security concerns you may have may prevent you from that. So you would need a big computer with a big SSD. Sometimes geth and parity fail. You need a robust implementation there. And I just put there a couple of URLs for the way we do this currently. It's price feed and medianizer. You can read the smart contracts. But I want to propose a better way to do this, and this is using signed messages. So the first advantage of signing a message with your Ethereum account is that it's free. It's totally free. An Ethereum account is nothing more than a public and a private key, and you can sign data with that private key. In fact, that's what a transaction is. It's just a signed message with a very specific way of signing specific data, such as the from, the to, the data, the nonce, gas price chain, all that kind of thing. So oracles need no with balance. They can just be signing messages all the time. You can move some of the calculation off-chain, as we'll see in a moment. You do not have to run a node. There are programs that will let you sign messages without running Geth or parity, and you can run our stuff on like a 5 USD VPS a month. And a couple of our newer GitHub repos are Median and Terra. So let's go back to the original prices. We had 220, 170, 235. So let's transform those to A. Then to uint 256, which is a format that Solidity likes and understands. We're going to use the same 3 Ethereum accounts without any balance, and we're going to assign these values as Ethereum messages. So this is live, so let's see if this works. And okay, here we go. These are 3 signed messages using the 3 Ethereum accounts that we saw before. And okay, we're good. The first one, we recovered back to the original account. Second one as well. And the third one as well. This is all running live. I'll show you in a second. This is not, this is all real. Okay, so how did it work? Right now I'm using sign and easy recover from the web3.eth.personal library. And it's just as simple as calling the sign method with the price and the account and an empty password, which you do not want to do in production. The price is just the price we saw converted to Wave, then converted to uint 256. And the account is the account that you want to sign with. And you get this message back, which is a 65-byte signature. And to recover that, you just grab the original data that you signed, which is the price, and the message, the 65-byte signature. You run it through Easy Recover, and you get the original Ethereum address to sign it. So as you can see, this is very powerful if you can whitelist addresses that can act as your oracles or as your wallet signers or basically anything you want. Just a quick word about the message. These 65 bytes are comprised of 1 byte for the V, which is the last part over in the message, the 1B, then 32 bytes for R and 32 bytes for S, which let's hope you can see. This is a simple version of our medianizer with no timestamps, no nonsense. It's just a little code to show you how this works. So you would grab the messages from all these accounts, put them in order first. So essentially there, you already save yourself from doing computation on-chain, since you can very easily grab all these messages, sort them by price, off-chain, and then just send them to the smart contract, which, as you can see, the only thing it'll do is down where you can see KECAC 256, you'll see the easy recover. That's doing the same thing that we did here in the presentation. It's going to grab the price, it's going to grab the hash message, and it's going to get back who signed that message. And as long as, in this next slide, you'll see up top that you have a whitelist of who can sign it, then essentially you've got a really nice oracle over there. You check that the values are ordered, you check for uniqueness, so they cannot send to prices signed by the certain oracle. And in the end, you just do a quick sanity check that the median is exactly the one that's in the middle. So some things to keep in mind, that this is not production ready. Like I said, we use timestamps, nonces, and some other magical stuff. And 3 oracles is not a lot. As you can see, the prices were not incorrect because the median turned out to be very accurate. But if you have 3 oracles, then if 2 collude, then you're going to have a bad time. For example, in production, we use about 14 of them. And you need a way to transport these signed messages. The nice thing about just using transactions is that everything is in the blockchain. But with this, you need a way to move all these messages between machines, and we use and love Scuttlebutt. There's a couple of other uses of signed messages. You can have a multi-sig wallet. A lot of wallets we see every day, somebody has to send a transaction to propose an action, then people have to send transactions to vote for them, and then the final person who sends the transaction and approves is the one that pays for all the gas. So why not just sign messages saying that you intend to approve a proposal, and then somebody else can just grab all these messages and send them for you, which is exactly the way that our medianizer does. As long as you can grab all these messages, anybody can send them, because only authorized signers will be able to actually change the state of the contract. They're very useful for relayers. We've seen a couple of implementations now. People can pay in their own tokens, or whichever token the relayer accepts, for the gas. And we're looking forward to seeing what else people come up with. Just quick detour. ETH is still 718.75. That's way too low. So that's my segue to just give a quick shout out to multi-collateral DAI, which is coming this year with a lot of improvements, including the stuff with the oracles that I mentioned. And just want to say that for the hackathon, we're going to have up to 4,500 DAI worth of bounties. And hope you can join our community. And over there's our URL, the chat, the Twitter, whatever. And we're always looking forward to talking with you about, well, mostly anything. I talk about oracles, but you can talk to me about whatever you want. So thank you. I just want to say that this is not, this is really a dApp. Those are all the errors that happened during. But if you want to see the source code, just go to GitHub MakerDAO ETH Berlin, and you can check it out and maybe send a pull request. Thank you.